In this video, we will be doing 3 proofs, 2 shorter proofs, the yellow and the red, and 1 longer proof in the green. You'll notice that we're not writing it down. The purpose of this is to go through the thought process so you can see it. Should you write it down on your own? Absolutely. First, we will do the yellow. Angle BAD is a right angle. So angle BAD is a right angle. Angle CAE is a right angle. Angle CAE is a right angle. Prove that angle BAC is congruent to angle DAE. So now you'll notice that angle CAD is part of this right angle here and is part of this right angle here. Therefore, complements of the same angle are congruent. Think 90 minus this, think 90 minus the same thing, you get congruent angles. Another way of thinking about it is this. It takes an extra step. Angle BAD is a right angle, angle CAE is also a right angle. Here in red, we're going to say that these are congruent angles. It makes it easier to see to do it in a different color. Then we're subtracting angle CAD from each. So if angle CAD and angle EAC are congruent, then subtracting the same angle from congruent angles results in congruent angles. Now over here, we'll start doing the proof in red and we'll use some different colors again. So angle GFH is congruent to angle JFI. Angle GFH over here is congruent to angle JFI over here. This time we're going to be adding the same angle instead of subtracting like we did in the yellow. So now we're going to prove that angle GFI is congruent to angle HFJ, GFI and HFJ. Now this time we're going to be adding an angle HFI. So if I add angle HFI to angle HFG, and if I add angle HFI to angle IFJ, I get congruent angles. I get congruent angles again because if the same angle is added to congruent angles, then the results are congruent. Make sure you can see this before you move on. Concepts from the yellow and the red will be used in the green. So now we move to the green proof. This one's a bit longer. We're going to write in yellow because it's easier to see. Here we go. JK is perpendicular to KM. JK perpendicular to KM, meaning that angle JKM is a right angle. NK and KL are perpendicular, meaning that angle NKL is a right angle. Angle KJL is congruent to angle KLJ. Angle KJL over here is congruent to angle KLJ right over here. Next, angle NKM is part of angle JKM and angle LKN. So there's 2 thoughts you could do here. Complements of the same angle are congruent, or subtracting the same angle from congruent angles results in congruent angles. So then these 2 angles are congruent. You can use complements of the same angle. You can use subtracting the same angle. Either one is fine. So now next, then we're proving that angle KNJ is congruent to angle KML. KNJ here and KML there. The reason for this is either called the no choice theorem or the third angle theorem. I'm going to number these to make them easier to talk about. 1, 2, 3, 4, 5, 6. If I have 2 triangles and angle 1 is congruent to angle 2, angle 3 is congruent to angle 4. 2 angles are congruent into these 2 triangles. Angle 5 and angle 6 must be congruent. Triangles always have 180 degrees, and that is everything. As stated before, the yellow and the red introduce concepts that are used in the green, which is a harder proof. If you can get this green proof, you are well on your way to being able to do proofs in geometry.